So when we're talking about a unimodal symmetric distribution or a normal distribution, both are ways to call that, we typically say that any observation past 2 standard deviations from the mean is, quote, unusual, because only 5% of observations fall that far out, 2.5% on either extreme. So again, going back to our master image here, anything past 2 standard deviations out, so anything out this direction, anything that falls out here, or anything that falls back here would be considered, quote, unusual. So again, only 5% fall that far out. So let's look at an example here. It says the city of San Francisco, California has a mean temperature of 65 degrees and a standard deviation of about 8 degrees. The city of Provo, Utah has a mean of 65 degrees as well, but a standard deviation of 21 degrees. We're going to use the empirical rule to decide whether it's unusual for San Francisco to have a day when the high temperature is 47 degrees, and also is that unusual for Provo. Okay, and again, what probably should be stated here is that the degrees are unimodal and symmetric in distribution. So both of them have a mean of 65 degrees, so that's right in the center. Now, we're looking for 47, so I'm not going to worry about marking off in the positive direction. I'm only going to go to the direction that I need. So I'm going to mark 1 standard deviation backwards. So if I subtract 8 from that, so if I do 65 minus 8, I land at 57, so that's this mark. That's 1 standard deviation below. So where's that 2 standard deviations below mark? So if I do 57 and then back up 8 again, I land at 49. So 47 is right here. That is past the 2 standard deviations from the mean. So yes, this would be unusual. For San Francisco, it's more than 2 standard deviations from the mean. Or I could even say below specifically here. So that would be considered unusual. Now let's look at Provo, Utah. So if we back up 1 standard deviation there, I would be doing 65 minus 21 in this case. So that's 44. Well, I don't even need to go any further than that. 47 is up here. So this would not be considered unusual at all. For the city of Provo, it's within 1 standard deviation of the mean. So it's kind of in that 95%, or sorry, 68% range. 68% of the days fall within 1 standard deviation of the mean, so this would be not considered unusual. So you can see how a certain value could be unusual for one situation and not unusual for the other, a different situation, depending on the mean and the standard deviation that we're talking about. Now we want to move on and actually use some technology to compute the standard deviation and the variance of a data set. Because these formulas are so much more complicated than finding the mean or the median, we are always going to use technology to do this. We are never going to do this by hand. And I have pulled back up that soccer goals and push-ups data again, where we are going to be looking at the soccer goals, and I've moved on to sheet number 4 in this case. So as a reminder, these are goals scored by first-year NCAA female soccer players in Division III in some certain season. This time, having the data in numerical order can mess up the idea of taking a sample, so I have just randomized the order instead. So it's the same list of soccer goals, just randomly jumbled up. I want to show you the difference between 2 different standard deviation and variance formulas in Excel, just to draw your attention to being very careful about using them. So first, we're going to assume these were the only 28 first-year NCAA female soccer players in Division III during this particular season. So if we have all 28 of their data values, then we actually have the entire population. So we are going to find the population standard deviation and the population variance for this first go around. Okay, so I'm going to minimize this so that we can do that. And here we have our two formulas. So notice that the difference is that it's either standard deviation.s and variation.s, or it's .p for the sample or for population. So to start, we're going to use the equals stdev.p formula. Highlight your data range, close it up, and hit enter. So there's my population standard deviation, and you can write that down on your worksheet if you want to. I'm going to keep a couple decimal places. I'm going to call that 4.87. Okay, and then for the population variance, we want to hit equals var.p. You can choose it. Close that up, and we get 23.67, it looks like. Okay, now what we're going to assume is that this is just a sample from some larger population, that there were more than 28 players, and for some reason we just took a small snippet of them. So in this case, we are trying to estimate the larger population standard deviation and variation based on just this sample. Okay, so this is an estimate. Whenever we did it up here, this was exact. That is the exact standard deviation and the exact variance of those values. But now we're saying, oh, this is just a sample. So now we're just estimating what that larger value is for that larger population. So the formula is a little bit different. So I'm going to type in stdev.s this time, choose my data range. Notice that it is a little bit different. It's close, but it's not exactly the same. So this is 4.95, let's say. And the sample variance, so var.s, pick the data range, is 24.55. So I just want to call your attention to that. Please be very, very careful in the wording of your questions. It will either tell you which one of those to use, or it will somehow specify that you have a sample or that you have a population, and you need to use the associated correct formula when you're calculating those, or you could get the problem wrong. If you just want to do the sample calculations, you can do a slightly different way. You can go to data and the data analysis and choose descriptive statistics off of here. You need to put in your input range. So let's say this, all of that. You want to make sure columns is selected. And then you have to select where you want to put this output. So I'm going to just skip down here somewhere to put this and check summary statistics. There we go. So notice this gives me a lot more than what I was just particularly interested. It gave me the mean, the standard error, which we haven't talked about, the median mode, but notice it did give the standard deviation and the variance, but notice that these values given are the sample values. So this only works, this kind of somewhat shortcut, I guess, way works as long as you're using, as long as you're looking for those sample values. You may also have a bit of a question because there is just enter stdev. So there is just a standard deviation formula. So you may be wondering, well, which one is that? Which one will that give me? So let's see if we highlight all of these, put that in there, let's check. Notice what that gives you when you just do the regular standard deviation. It gives you the sample. Okay, so it's sort of the default. Same thing with variance. If you just hit variance, it will also give you the sample variance. So Excel assumes that you only have a sample and that you're trying to estimate these about a larger population unless you very specifically tell it, no, I have every data value. It's so rare to have every data value that's why that one, I guess, is really different than all of the other ways to get these, because all these other ways are the more likely scenarios where you are just dealing with a sample.